So already during one of my experimentations, I have found that 280, 292 is an ambiguous pixel. So let us look at it, whether I have taken the same image. You don't know, 280 by 292. 280, 290. Okay, it's very difficult to trace the same point. So let us assume maybe the same image or different image. 280, 292 is one of the ambiguous pixels. So likewise, in your experimentation, you can take any point. Any point can be taken as an ambiguous point. Now we can take this 228 by 268 as one of the ambiguous point, or somewhat above also you can keep. So this is somewhat inside the optical disc only. So this can be ambiguous point 232, 274. Maybe an ambiguous pixel, and the patch can be generated around the particular ambiguous pixel. So how to do that patch? So 25 by 25 patch only I told. So three different sizes of patches we are going to generate. That is 25 by 25. What I wanted to create. You look at it. So these are the images that have to be worked out for patch generation and patch wise. You open this. Already I have decided I am going to generate patches of size 25 by 25, 29 by 29, and 33 by 33. To start with and to understand the concept 3 by 3 patch, how to generate a 3 by 3 patch. Suppose the ambiguous pixel is 280, 292. The formula is m minus k minus 1 by 2. So this is for the row entity and this is for the column entity. What we need to do is k is nothing but the size of the patch you are interested in. So size of the patch you are interested in a 3 by 3 patch means, so be clear, this is row starting and ending, column starting and ending. So don't think this is row and this is column. Obviously we have that confusion always. So row entity starting and ending, column entity starting and ending. In such a way we are going to generate the point of patch of interest, the spatial coordinates of the patch of interest we are going to say here. So for example, a 3 by 3 patch in the sense, 3 means k is 3. So 3 minus 1, so that will become 1. So what is a 3 by 3 patch? We can say the 3 by 3 patch will be 280 means we have to subtract 1 and add 1. That is 2 for 280, 279 is to 281, and 292, that is 291 is to 293. So this will create a 3 by 3 patch. Similarly, for a 25 by 25 patch, for a 25 by 25 patch, what we need to do? That means 25 minus 1 divided by 2, that will be 12. So m minus 12 to m plus 12. So you have to subtract and add 12. That means 268 to 292 row. So this is the row spatial coordinate, and the column spatial coordinate is minus 12 and plus 12 again, 290 to 304. So this will create a patch. So already we have these things in the program. So now im tool, let us minimize because we are going to the main program. As we come to the main program after, so I have written the comments for 3 by 3 patch and 5 by 5 patch also. And now what to do is how to name the particular image is also very, very important. Okay. A280, 292. That means, okay, let us discuss about the file naming later. That is 268 is to 292. The rows I want is, the actual image is A. So in A, the actual image is being named as A. So don't look at this B. This B is the variable taken for taking im tool. So in the A, what I want, 268 to 292 row. That's what I want. 268 to 292 row and 280 to 304 row. And 280 to 304 row I want, comma all. So this colon means all. That means for all the channels, red, green, and blue channel, we want it. And finally, we are putting it as im show of this one. Okay. So I think the entire program is being done. Already I selected the first 3 lines and given run select. But in MATLAB online, sometimes when we do run select, it runs the entire program. So likewise, it's not wasting our time. Already a 25 by 25 patch is being created. So that is what is a patch we wanted to create, a 25 by 25 patch. And how to name the file. That's what we are going to do. And what is more important is how to save this particular patch. So if you go to this icon, so click save. First you can save in MATLAB drive only, then only you can download. So when you want to name the file, select MATLAB drive and then go to here, how to save the file. So image name, so I am simply copying this here. Putting it here, image name. So 280 by 292 is the is the spatial coordinate, central point of that particular pixel, and 25 by 25 is a patch size. So these are all somewhat important. Means image name followed by center pixel coordinate followed by size of the patch being generated. So 25 by 25 patch is being generated. Now you have to know the image name. What is the image name? Just come here. So image name is nothing but the actual image name. Whatever image you have learned here, you have downloaded from here. I think Drishti GS002 only we have read there. So simply copy this and give rename, and give Control C. Go back to this environment. So all these things are very important. From which image you are generating the patch. All those informations are there. I don't know for time being, whichever file name I'm giving is right or not. Okay, so assume GS underscore 002 is the image and the patch is taken around the coordinate 280 by 292. 280 comma 292 is the center pixel, and around that pixel 25 by 25 patch I have created. I'm just going to save this. It has been saved in my MATLAB drive. You can download that. Directly go to the downloads. Most important thing is where to save it. Okay. Images one is the output folder to save output patches and patch wise. So 25 by 25 patch we have created. That is important. In the output images you have to save this. So this is the corresponding image. Let me check whether the file name is correct or not. Drishti GS004. That is a proper file name. So before starting to work out the patch, you can have in memory the file name also, Drishti GS. So this is the patch being created. So 25 by 25 patch has been created. So for the same patch, we need to generate the label also, isn't it? So Drishti GS004 is available in the training images. But what about the label? Drishti GS004 optical disc segmentation map. Here also around the same pixel, you need to create the patch. So what we can do is copy the label. Okay, directly copying and pasting may not be possible. You need to upload. Drishti GS004 is the first experimentation that is being done. So for the same image, I am taking the label also. So the particular label will be uploaded. Simply change the file name here. Whenever you want to give the file name as input to the program, to the coding part, just do like this. There is a small gap will lead to some errors. This here. First, let me run. Let me clear all. As we are working the MATLAB in online, it takes some time. Okay, so I have saved everything. So let me first run the first line alone. Let me pray it runs only the first line. Because it's an RGB image or a black and white image. It looks like a black and white image. If it is a black and white image, accordingly some changes we need to do in the program. For our luck, it is taking the running the full code only. It's now showing the in tool. This may not be required for me. But what I was interested to know is, it's not a RGB image. If it were an RGB image, it would be 512 by 512 by 3. So what change I can do in the programming is, I can turn off this in tool. Why? Because we already know the ambiguous point. That is what we are supplying here, the value. Because for the same spatial coordinate in the original image, we are picking up the same spatial coordinate from the label also. Now we have given the label as the variable name A, and we have again resized the label also to the same size. And after that, what we need to do is we need to switch off this RGB plane because it is a grayscale image. We wipe off everything. So I don't want in tool. It has generated the label patch. So let me save it. So there are some blocking artifacts here. That needs to be addressed in pre-process steps. It's not the concern now. Then I'm saving it to the drive. How it should be saved? Label name followed by the spatial coordinate _25. It's a file name we have taken. You know it from here. So always don't hesitate to take it from here. Just click rename. You have the chance to Control C and copy that. Don't rename it here because that causes lots of confusion in the coding. Okay. So just click rename for the purpose of copying that. What I'm doing is, it's a simple shortcut. put the label name here. So what I will do, I will automatically understand from which optical disk map it is taken and what is the coordinate it is being taken and what is the size of the patch. Every information is given here. So save it. You need to download it. So where we need to put it in patch wise, patch 25 we have created. So go to patch 25 and output images. One image is already worked out. Drishti GS004. For the same image, we are going to put the label. And that's it. So one particular patch and the corresponding label patch is also generated. Likewise, for each single image, what I told is, for each single image, we need to generate 10 patches. Okay. So 10 patches for single size. That is 25 by 25 means 10 patches. 10 patches and 10 labels. Okay. And similarly, not only then around the same spatial coordinate, you need to generate the 29 by 29 patch and 33 by 33 patch. It would be comfortable to work like 25 by 25, then 29 by 29 and 33 by 33 patch for the same location, and then come to the label. Work for 25 by 25 patch, 29 by 29 patch and 33 by 33 patch and save the labels. Then go to the second ambiguous point. Likewise, 10 ambiguous points you can go. For each ambiguous point, 3 patches, 3 size of patches, and again the label of 3 different size of patches. That's what we need to bring. So I will repeat it. For each image, you take a single image, the patch database that is supposed to be created, what we have to do is, we have to look at 10 ambiguous points. At a single ambiguous point, you need to generate a 25 by 25 patch. Immediately you can change the code for 29 by 29 patch and 33 by 33 patch also, and they can be saved accordingly. Then go to the next ambiguous point, then go to the next ambiguous point. Likewise, 10 ambiguous points you take, and for the image you create the patches of size 3 different sizes. Okay, and after that the label patches can be generated for the same location. In such a situation, you need not open the label. Okay, so for the corresponding image, what is the label, you know. So simply change the file name in the program. So whatever I did for 004, what I need to do, simply repeat the same procedure for copying this file name and running the code again and again for different spatial coordinates and for different patch sizes. That is what is the patch database generation. Thank you.